familiar with it. Be happy to answer any questions that we can. We have arranged a tour for you so that we can.
Construction started in 1971. They went operational in 1974. The reason for WESF was to convert the radioactive cesium and strontium into a solid form. The capsules are about 20 inches long. They're double encapsulated stainless steel capsules. The salt was put into the inner capsule and then welded up, and then put into a second capsule and then welded up. And we currently store these capsules in our storage pools. They're stored in 13 feet of water. The capsules, a portion of the capsules were shipped off-site and used at irradiators. Those were recalled by DOE and they were brought back. We completed the recall of the capsules, and the last shipments were received in 1997. The capsules are stored in the pool cell in a vertical orientation at the bottom of racks, and we have 13 feet of water in the pool cell, so about 11 feet of water over the top of the capsules. That water there provides shielding of the radiation coming off the capsules. It also is circulated through heat exchangers with 3 circ pumps to cool the water, because we need to remove the heat that's generated off the decay of the capsules coming off.
I work for the Department of Energy, Richland Operations Office, and for a short while longer for I guess. The fuel that's stored out here is not, that's just a metal warehouse type shell there. The below grade vaults, the burn up of the MOX fuel is. I probably have a technical expert.
The multi-canister overpacks are approximately 14 feet in length.
So it's WTP coming online at that time in 2016. And
The multi-canister overpacks, in this case, is production-related fuel from the predominantly from the N reactor, and clearly the supermajority of the fuel is from the N reactor. The N reactor fuel had been temporarily stored in underwater at the K basins, both the K East and K West basin in the Hanford area of the Hanford site along the river. And of course, part of the goal is to get some of those curies away from the river. The canister storage building vaults, only vault 1 is finished. It was originally dedicated for the high-level waste vitrification canisters that were coming over here. So the other 2 vaults could be retrofitted should the waste treatment plant decide to use this as part of their storage capacity.
The K basins are 2 indoor concrete pools attached to closed nuclear reactors that were once used to produce plutonium for national defense. The basins are located near the Columbia River, about 35 miles north of Richland, Washington, on the Department of Energy's Hanford site. Each basin is roughly 1/3 the size of a football field and 20 feet deep. For many years, the basins held the largest collection of spent nuclear fuel of any Department of Energy site in the nation. Spent fuel is fuel that has been irradiated in a nuclear reactor, making the material very radioactive. Government contractor Fluor Hanford finished a huge project that removed 2,300 tons of spent nuclear fuel, nearly 5 million pounds, from the basins in 2004. They dried the fuel and placed it into safe storage in a large facility in central Hanford, safely away from the Columbia River. During the spent fuel campaign, Fluor Hanford workers removed more than 50 million curies of radioactivity, which was 95% of the radioactive material along the Columbia River. Then they welded permanent covers on the fuel casks.